All right, we'll go ahead and try this podcast lesson. Um, what the general purpose of this is to get me from in front of y'all in the classroom and actually have you sitting down with your little iPods listening to this and see if this helps you anymore to be able to go back and listen to it again, go back over information that you need. You can work at your own pace. We're gonna look at weather, climate, and heat transfer. It's all stuff we've been talking about for the past couple of weeks. So you can use your notes to help you out with this, your science sources, as well as this podcast. You can go back and listen to it again. I'll make sure to put it on the website also, ogreensclass.blogspot.com if you haven't checked it out. So I'm gonna go ahead and get started. All right. First thing I want to remind you about is weather and climate. Remember, weather deals with your local winds. It's day-to-day conditions in the atmosphere. Your climate has more long-term effects. All right, it happens over a long period of time. It anywhere from 100 years to 1,000 years. Climate can encompass all of that. We've talked about that in class, where we said your global winds that take longer to change and they cover a much larger area. Those are the ones that's going to affect your climate, and your weather is going to be affected by your local winds that change just about every day, every few hours they're changing, and that's going to go ahead and give you your weather and your climate. So those things you should be able to differentiate between the two, and you should be able to go forward and figure out what those are. If somebody asks you, what's the difference between weather and climate, you should be able to tell them. Also, when we were talking about weather and climate, we talked about cold fronts, warm fronts, and occluded fronts. And if you don't remember what those are, if you're not sure what those are, on your weather charts, those are some of the things that they ask you to check for: the cold fronts and warm fronts, or what type of fronts we're passing through. I'll give you a brief little overview of that. Your cold fronts, all right, they clearly gonna bring cold weather. Um, they're they come at the leading edge of a cold air mass, so that's why it's called a cold front. It's the front of the air mass. It's going to usually bring some pretty severe weather and storms, hail, snow if it's cold. If it's not cold, it's going to bring heavy rains, thunderstorms, tornadoes. You get all those type of weather events from your cold fronts. Your warm fronts, those are going to be they're going to bring warm weather. They're going to happen at the leading edge of warm weather. When warm weather is coming through, you're going to have rain showers and moderate rainstorms. It's not going to necessarily be anything heavy. Um, the way that you see them on a weather map, your warm fronts will have a red line with little half circle shapes. Your cold fronts will have a blue line with triangle shapes. And the third front that you need to know about is called an occluded front. OCCLUDED front, occluded front. And those fronts are basically fronts that are stuck. They're halfway in between a cold front and a warm front. They're not moving. They're staying in one spot, and they'll bring scattered showers and storms and stuff like that. All right. Next thing we talked about the Coriolis effect. All right. Remember, the Coriolis effect is going to keep things from moving in a straight line on Earth. If you're going from the North Pole to the equator, things are going to drift to the right. If you're going from the South Pole to the equator, they're going to drift to the left. And that Coriolis effect, that drifting of you know anything trying to move in a straight line, is going to allow us to get all of our different currents, our different ocean currents, wind currents. Those are all due in part to the Coriolis effect. All right, and that Coriolis effect comes from the rotation of the Earth. Since the Earth is constantly moving and rotating, uh, you get the Coriolis effect. All right. Um, oh, the one place on Earth where you're not going to find any wind, that's called the doldrums. Doldrums. Doldrums, and those are found right along the equator. All right, and if you think about it, the equator is sort of like our fire for the on the pan. All right, it's gonna heat things up. Okay, so right at the equator, you're not gonna necessarily have any wind because the wind is being generated from that area. So, like I said, there's a narrow band right near the equator that has absolutely no wind, and those are called your doldrums. All right. Uh, Conduction, convection, and radiation. Conduction is just like it says, it's when two things are in contact. Conduction, contact. All right. Conduction is when you heat something by direct touching, direct heating. Okay. Conduction, direct. Conduction, direct. All right, get that in your head. And what you do with your conduction, that's like sticking a pot on the stove. All right, those two pieces of metal are touching each other, or the metal's touching the fire, or whatever heating source that you have, and those two are touching each other. Okay, so since they're touching, that's conduction. All right, conduction is heating by touching. All right, two things have to touch in order to be heated. Convection, on the other hand, is when you heat by just moving the molecules that are around, moving the air. All right. So if you stick something in an oven, all right, it heats up not because it's sitting on the hot part of the oven. It's because the air inside of the oven gets heated up and it starts to move in those convection currents. The warm air rises, the cool air sinks, and then eventually all of the air on the inside becomes relatively hot. It becomes warm. All right. So those are that's your convection, and that's why we talk about convection currents. We see them in global weather patterns. We see them in the water cycle. You see them all over the place. All right, so convection. Most of the cycles that we're talking about could be convection, where you have something warm that's rising, something cold that's sinking. Um, and in radiation, that's where things move by electromagnetic waves. And what that simply means is that anytime that you have light, anytime that you have X-rays or things like that, those are all types of radiation. So that means they don't necessarily need anything to move through. Light, it can move through whatever's there. It can move through air. It can move through no air. That's how we get light from the sun. There's no air in space, but that light's still able to travel through to us. Okay. Your cell phones, those work on radiation waves. All right, and that's why people tell you, don't hold your cell phone to your ear because then you'll get brain cancer because of the radiation. All right, so that radiation is something that is another way for heat to be transferred amongst a couple of different items and things. All right, your topographic maps. All right, remember we talked about topographic maps are simply maps that show you the contours of the land. They also show you the elevation and any landforms. So if you have mountains and rivers, valleys, lakes, those are all shown on topographic maps. All right, so if you have a topographic map, they're used. You use contour lines in order to make the maps. All right, those contour lines have intervals, and those intervals basically tell you the amount of elevation that the map goes up by. Um, you can look in your notes and see the difference between your steep elevations, your flat elevations, your valleys. All right, those are all shown to you on a contour map. All right, those maps aren't going to necessarily give you the directions of how to get to somebody's house, but they'll be able to show you whether somebody's house is built up on a hill, on a cliff, or on flat land. So that's what your topographic maps are going to be for. All right. I guess the last thing I want to hit on is the grades. I was doing some grades this weekend and they weren't really all that good. Folks aren't turning in work. They're not participating in class, and the grades are really suffering because of that. So I've given you your grades already, or you'll get your grade again once you get to the end of these questions. If you have below a 70, you need to go to the website ogreensclass.blogspot.com and do one of the two assignments that's on there, and I'll use that and replace your lowest assignment. So make sure that you're getting the make sure that you do those. You have until the Monday after Thanksgiving to turn it in, so you have plenty of time to do it. Please take advantage of that, because right now it's not looking good for a lot of folks. And if you're not one of the folks, congratulations, good job. If you are one of the folks, then you need to go ahead and turn it up and start start doing start doing better. All right. We still have time for you to do better. We still have time for you to pick your grade up. So please take advantage of that. All right. Um, what else I'd like you to do is, once you finish answering these questions, all right, if there's any homework that you haven't completed, either get it. You can come ask me for it. I should have some extra copies. Also, you may want to ask one of your neighbors to see if you can, get it from them if if they're done. But as you finish this, make sure you do all of the 15 questions that are on the worksheet that I pass out to you. Make sure you take your time to do it. Use your strategies. Okay. You're gonna answer these in your notebook. All right. You're gonna paste the worksheet on the right hand side, and you'll answer your questions on the left hand side. All right. If you have any questions, they should all be answered on this podcast. If not, raise your hand. I'll come around and help you out. And if this works, we'll see if we could do some more lessons like this. And if you like these type lessons, just write a, you know, just let me know. Let me know when I come around. Just raise your hand and tell me if you like doing this, what else you'd like to see done, and hopefully we can get some of the computers in and use those to do it also. But for now, I guess that's about it. Have a good day. Good luck. If you have any questions, check your notes, check the Sciencesaurus books, and have a good day.